Hi, hello students, welcome back to our channel. This is Bhaskar Bora. We are discussing 10th class mathematics 3rd chapter polynomials. As in the part of this chapter, today we are going to discuss the problems which are given in exercise 3.3. So let us first see the first bit problems from exercise 3.3. So the first problem is given as find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Here we were given by some quadratic polynomials and we need to find the zeros of those polynomials, and then we need to verify the relationship between the zeros of the quadratic polynomial and its coefficients. So let us first see the first problem from the first bit. The first problem is given as x square minus 2x minus 8. So here the given quadratic polynomial is x square minus 2x minus 8. Now we need to find the zeros of this quadratic polynomial. So to find the zeros of this quadratic polynomial, we need to equate this polynomial value with 0. So by equating this polynomial with 0, we get x square minus 2x minus 8 equals to 0. Now, to find the zeros, we need to factorize this equation. For this, we need to split the middle term, that is minus 2x. How can we split the middle term? By taking the suitable pair of factors of the product of x square coefficient and x square coefficient and constant. So here, what is the x square coefficient? It is 1. And what is the constant here? It is minus 8. So the product of 1 and minus 8 equals to minus 8. Now we need to think of a suitable pair of factors for minus 8 such that the sum of the factors of this minus 8 should be equals to x coefficient. So here x coefficient is what? Minus 2. So here we need to take a suitable pair of factors for minus 8 whose sum is equals to x coefficient, that is minus 2. Now tell me, what are the suitable pair of factors that we need to consider here? Very good. The suitable pair of factors here we need to take minus 4 and 2, since their product is equals to minus 8 and the sum of those two factors equals to minus 2. So using minus 4 and 2, we can split the middle term, that is minus 2x. So let us split it. We can write x square, and the next term minus 2x can be splitted as, using minus 4 and 2, we can write it as minus 4x plus 2x. And the next term is minus 8. So minus 8, which equals to 0. Now if we observe this equation, in this the first two terms, that are x square and minus 4x. In these two terms we have x as common. So let us take x as common out. By taking x as common out, we get x minus 4 in bracket. And in the next two terms, that are plus 2x minus 8, we have 2 as common. So by taking 2 as common out, we get x minus 4 in bracket, which equals to 0. Now observing this equation again, we have x minus 4 in common. So by taking x minus 4 as common out, we get x plus 2 in bracket, which equals to 0. So now what we get? X minus 4 into x plus 2 equals to 0. Here the product is becoming 0. That means any one of this product must be equals to 0 or both equals to 0. So we can take x minus 4 equals to 0, or we can take x plus 2 equals to 0. By simplifying these, we get x equals to 4 or x equals to minus 2. Now we get the required zeros for the given polynomial as 4 and minus 2. So here 4 is the first zero and minus 2 is the second zero. Now let us verify the relationship between these two zeros with the coefficients of the given quadratic polynomial. For that, let us assume the first zero as alpha and the second zero as beta. So alpha equals to 4 and beta equals to minus 2. Now let us verify the sum of the zeros, that is alpha plus beta, which equals to Here alpha is 4 plus beta equals to minus 2. So by simplifying this, we get the sum of the zeros as 2. If you want to compare this sum with the coefficients of given quadratic polynomial, here 2 is related with x coefficient. But if we observe the given quadratic polynomial, the x coefficient we have as minus 2. But here we get the positive 2 as the sum of the zeros. To compare this 2 with the x coefficient, we need to express this 2 with a negative sign. For that, we know that a positive number can be expressed with a negative sign as minus of minus. So now we can write this positive 2 as minus into minus 2 by 1. So what we did here, we expressed the positive 2 as minus into minus 2 by 1, so that we can compare this fraction with the coefficients of the given quadratic polynomial. Now if we compare the numerator, here we have in the bracket minus 2, which is nothing but it is the x coefficient. So we have minus of x coefficient in the numerator, and in the denominator, that is 1, it is nothing but it is the x square coefficient. This can be related as minus x coefficient by x square coefficient, which is nothing but minus b by a. Now we verified the sum of the zeros. Let us verify the product of the zeros. So the product of the zeros, that is alpha into beta equals to, so here alpha is 4 and beta is minus 2. So we get 4 into minus 2, whose product equals to minus 8. And if we observe this minus 8, if we compare with the coefficients of given quadratic polynomial, this minus 8 is related with which term in the given quadratic polynomial? Very good. It is related with the constant term. In the given quadratic polynomial, we have minus 8 as the constant term. So this minus 8, we can write it as minus 8 by 1. Now this can be related with the coefficients of the given quadratic polynomial, that is x square minus 2x minus 8. Here in the numerator we have minus 8. It is related with the constant term in the given quadratic polynomial. And in the denominator we have 1, which is nothing but it is the x square coefficient. That means this minus 8 by 1 is related with the coefficients of the given quadratic polynomial as constant by x square coefficient, which can also be written as c by a. So in this way we verified the relationship between the zeros and the coefficients of the given quadratic polynomial. Now let us see the second problem. The second problem is given as 4s square minus 4s plus 1. So here we have a quadratic polynomial in variable s. Here the variable is s. Now to find the zeros, first what we have to do, we need to equate this polynomial value as 0. So we get 4s square minus 4s plus 1 equals to 0. Now we need to split the middle term to get the zeros of this polynomial. So what is the middle term here? Minus 4s. To split the middle term, that is minus 4s, we need to take a suitable pair of factors for the product of s square coefficient and constant. So here what is the s square coefficient? It is 4. And what is the constant here? It is 1. So the product of 4 and 1 equals to 4. And we need to think of a suitable pair of factors for 4 such that the sum of those two factors must be equals to s coefficient. So what is the coefficient of s here? We have minus 4. So we need to consider a pair of factors for the product 4 such that the sum of those two factors must be equals to minus 4. Now tell me which pair of factors we need to take for the product 4. Very good. We have to take minus 2 and minus 2 because the product of these two equals to positive 4 and the sum of these two will be equals to s coefficient, that is minus 4. So let us take minus 2 and minus 2. Using these two, let us split the middle term minus 4s. For that let us write 4s square and minus 4s can be written as minus 2s and minus 2s plus 1 which equals to 0. Now in the first two terms we have 2s as common, so by taking 2s as common out we can get in bracket 2s minus 1. Now again if we see in the next two terms that are minus 2s and plus 1, here we can take minus 1 as common out. So by taking minus 1 as common out we get 2s minus 1 in bracket which equals to 0. So now again we have 2s minus 1 in common, so by taking it as common out we get 2s minus 1 into 2s minus 1 which equals to 0. Now this product is becoming 0, that means either any one of this product must be equals to 0 or both equals to 0. So let us take 2s minus 1 equals to 0 or 2s minus 1 equals to 0. By simplifying these we get s equals to 1 by 2 or s equals to 1 by 2. So here we get the two zeros as equal. So that means this quadratic polynomial has two equal zeros, that are 1 by 2 and 1 by 2. Now let us verify the relationship between the zeros and the coefficients of the given quadratic polynomial. For that let us assume the first zero as alpha and the second zero as beta. The first relationship, that is sum of the zeros. Alpha plus beta equals to, here we can take 1 by 2 plus 1 by 2, and by adding half plus half. So now 1 by 2 plus 1 by 2 means half plus half equals to 1. So we get the sum of the zeros as 1. Now this sum should be compared with the coefficients of the given quadratic polynomial, and we know that the sum of the zeros are related with minus x coefficient by x square coefficient. But if we observe in the given quadratic polynomial, here the s coefficient is minus 4, we have minus 4, and the s square coefficient is 4, but here we get the sum as 1. That means here we do not get minus 4 by 4 here, just simply we get 1 as the sum of the 0. That means we have to think of here how can we express this sum, that is 1, in terms of minus 4 and 4. Yes, we can write this one as 4 by 4, but here the s coefficient is negative 4 we have, but if we write 4 by 4 we get positive. So in the numerator we should get negative 4. For that we can write the positive 4 as minus into minus 4. So that means 1, this 1 can be expressed as minus into minus 4 by 4. Now we can able to compare this with the coefficients of the given quadratic polynomial, that is 4s square minus 4s plus 1. Now here in the numerator we have minus 4 in the bracket, which is nothing but it is the coefficient of s. So we get minus s coefficient in the numerator, and in the denominator we have coefficient of s square. So this is nothing but it is minus b by a. Now let us verify the product of the zeros, that is alpha into beta. Here alpha is 1 by 2 and beta is also 1 by 2. So by multiplying 1 by 2, 1 by 2, we get the product as 1 by 4. And if we observe this fraction, here in the numerator we have, it is related with the constant term, and in the denominator we have 4, which is related with the coefficient of s square. So we can write this as constant by s square coefficient, which is nothing but c by a. So now we verified the relationship between the zeros and the coefficients of the given quadratic polynomial, that is 4s square minus 4s plus 1. Similarly, let us do the next problem. So the next problem is given as 6x square minus 3 minus 7x. Here if we observe this quadratic polynomial, here it is not in the standard form. That means the terms in this polynomial are not arranged in the decreasing order of their degrees. So further let us first arrange this quadratic polynomial in the decreasing order of their degrees. So here the term 6x square as the highest degree, that is 2. So let us write 6x square term as first, and then the minus 7x is the term with next highest degree. So we have to write minus 7x in the second place. and minus 3, which is the constant term whose degree is 0, it will be in the third place. So by writing the given quadratic polynomial in the standard form, we get 6x square minus 7x minus 3, and let us equate this polynomial value with 0 to find the zeros of this polynomial. So we get 6x square minus 7x minus 3 equals to 0. Now to find the zeros, first what we have to do? We have to split the middle term, that is minus 7x. To split the minus 7x, we need to take a pair of suitable factors for the product of x square coefficient and constant. Now here x square coefficient is 6 and constant is minus 3, and whose product is equals to minus 18. Now we need to think of a suitable pair of factors for minus 18 such that the sum of those two factors must be equals to x coefficient. In this case, the x coefficient is minus 7. So think of what are the suitable pair of factors for minus 18. When we add those two factors, we get the x coefficient, that is minus 7. Very good. The suitable pair of factors for minus 18 in this situation are minus 9 and 2. So by taking minus 9 and 2 here, we can split the middle term minus 7x. So let us split minus 7x using minus 9 and 2. So by doing that one, we get 6x square minus 9x plus 2x, which equals to minus 3 equals to 0. Now in this equation, if we observe the first two terms, that are 6x square minus 9x, in these two terms we have 3x as common. So let us take 3x as common out. By taking 3x as common out, we get 2x minus 3 in bracket, and in the next two terms, that are plus 2x and minus 3, here nothing is common for these two terms, so we can take 1 as common out. By taking 1 as common out, we get 2x minus 3 in bracket, and which equals to 0. Now if we observe, again we have 2x minus 3 in common in these two terms. So by taking 2x minus 3 as common out, we get 3x plus 1 in bracket, which equals to 0. Now we get the product of 2x minus 3 and 3x plus 1 equals to 0. That means either any one of these two, that are 2x minus 3 and 3x plus 1, should be equals to 0. So we can take 2x minus 3 equals to 0 or 3x plus 1 equals to 0, and by simplifying these, we get x equals to 3 by 2 or x equals to minus 1 by 3. So now we get the zeros of the given quadratic polynomial as 3 by 2 and minus 1 by 3. Now let us verify the relationship between the zeros and the coefficients of this given quadratic polynomial, that is 6x square minus 7x minus 3. For that, let us assume the first zero as alpha and the second zero as beta. Here alpha equals to 3 by 2 and beta equals to minus 1 by 3. Now let us verify the sum of the zeros, that is alpha plus beta, which equals to 3 by 2 plus minus 1 by 3. So by simplifying this, we get 9 plus into minus 2 by 6. So by simplifying this, we get 7 by 6. Now if we compare this fraction with the coefficients of the given quadratic polynomial, in the numerator we have positive 7, seems to be related with the coefficient of x, that is minus 7. But we have negative 7 as the x coefficient, but here we have positive 7 in the numerator. So to compare this 7 with x coefficient, that is minus 7, we can write this positive 7 as minus into minus 7, and 6, here 6 is the coefficient of x square. So this 7 by x can be written as minus into minus 7 by 6. Now here in the numerator, minus 7 is the coefficient of x and 6 is the x square coefficient. So this can be written as minus x coefficient by x square coefficient, or we can say minus b by a. So we verified the sum of the zeros, and now let us verify the product of the zeros, that is alpha into beta. So here alpha equals to 3 by 2 into beta equals to minus 1 by 3. So by multiplying these two, we get the product as minus 3 by 6. Now this minus 3 by 6, if you want to relate this with the given quadratic polynomial, here minus 3 is nothing but it is the constant term and 6 is nothing but it is the x square coefficient. So we can write this minus 3 by 6 as constant term by x square coefficient, or we can say c by a. So hence we verified the relationship between the zeros and the coefficients of the given quadratic polynomial 6x square minus 7x minus 3. So in this way, let us do the next problem. The next problem is given as 4u square plus 8u. Here, if we observe this quadratic polynomial, here we have only two terms, and that are 4u square plus 8u. So in this, the constant term is not given. So in the place of constant term, we may write 0 also. Now, let us first find out the zeros of this quadratic polynomial. For that, let us equate this polynomial value as 0. So we get 4u square plus 8u equals to 0. Now, if we observe these two terms, in these two, what is common here? Very good, 4u is common. So let us take out 4u as common out. So by taking 4u as common out, we get in bracket u plus 2, which equals to 0. Now this product is equals to 0. That means either any one of this product should be equals to 0 or both should be equals to 0. So we can take 4u equals to 0, or we can take u plus 2 equals to 0. And by simplifying these two, we get u equals to 0 or u equals to minus 2. So what are the two zeros that we get here? The first 0 as 0, the first 0 as 0 and the second 0 as minus 2. Now let us verify the relationship between the coefficients of the given quadratic polynomial with its zeros. So for that, let us assume the first 0 as alpha and the second 0 as beta. Now let's verify the sum of the zeros, that is alpha plus beta, which equals to 0 plus of minus 2. So now the sum of these two zeros equals to minus 2 we get, and this minus 2, if we want to relate with the coefficients of the given quadratic polynomial, in the given quadratic polynomial it seems to be there is no coefficient with minus 2, and we know that the sum of the zeros is related with minus x coefficient by x square coefficient, but here instead of variable x we were given by variable u, so we have to take minus coefficient of u by coefficient of u square. So here what is the coefficient of u? That is we have 8, and the coefficient of u square is 4. Now let us think whether we can write this minus 2 using the coefficients of u and u square, that are 8 and 4. Yes, so we can relate this minus 2 with the coefficients of u and u square. So how? We can write this minus 2 as minus 8 by 4. So here 8 is nothing but it is the coefficient of u, and 4 is nothing but coefficient of u square. Now we get minus u coefficient of u and coefficient of u square, which is nothing but minus b by a. Similarly, let us verify the product of the zeros, that is alpha into beta, which is nothing but 0 into minus 2. So 0 into minus 2 equals to 0. Now this 0 can be related with the given quadratic polynomial, coefficients of given quadratic polynomial as 0 by 4, which means 0 here nothing but constant. Since in the given polynomial constant is not given, so we can write this as constant, and by 4 is nothing but coefficient of u square. So we get constant by u square coefficient, which is nothing but c by a. Hence we verified the relation between the zeros and the coefficients of the given quadratic polynomial. Now let us see the next problem. It is given as t square minus 15. So here also in this one term is not given, that is the term with t. So in the place of second term we may take as 0t. So now let us find out the zeros of this quadratic polynomial. For that, let us equate this polynomial value as 0. So we get t square minus 15 equals to 0. Now we can transpose minus 15 to right hand side. So by transposing minus 15 to right hand side, we get t square equals to 15. Now let us transpose the square on the right hand side. So we get t equals to square root 15. You know that the square root of any number will be taken as positive and negative. So here we can take t value as one value as positive and another value as negative. So here we get the zeros of the given quadratic polynomial as one is square root 15, that is positive 15 root 15, and the second one is negative root 15. Now let us take one as alpha and the second one as beta to verify the relationship between the zeros of the given quadratic polynomial with its coefficients. Now let's verify the sum of the zeros, that is alpha plus beta equals to root 15 plus of minus root 15, and whose sum is equals to 0, and this 0 can be expressed as minus 0 by 1, so that we can relate this with the given coefficients of the given quadratic polynomial. So here 0 is nothing but it is the coefficient of t. The term with t is not given here, so we can take the coefficient of t with 0. So we can write this as minus t coefficient by 1 is here the coefficient of t square. So we can write t square coefficient which equals to minus b by a. Now let's verify the product of the zeros, that is alpha into beta. So that we can do root 15 into minus root 15. By doing their multiplication we get minus 15, and this minus 15 can be written as minus 15 by 1, so that we can relate this with the coefficients of the given quadratic polynomial. So here minus 15 is nothing but it is constant, and 1 is nothing but it is the coefficient of t square. So which means we get the product of the zeros as c by a. Hence we verified the relationship between the zeros and the coefficients of the given quadratic polynomial. So in this way we can verify the relationship between the zeros and the coefficients of the given quadratic polynomial. It is all enough today. Let us meet in our next video with the next bit. Till then, bye. Thank you.